Good morning, good afternoon, good evening, depending on the time and where you're watching from. As I welcome you once again to Solution to 2025 WAEC Past Question in Chemistry. This is our day 6. In this day 6, we'll be starting from question number 32 down to question number 36, already written on the board. Question 32. A salt that could be prepared by double decomposition is A. Sodium trialkyl 4, barium trialkyl 5, lead 2 trialkyl 5, silver chloride. Now, for you to get the correct option of this question, you need to know that there are two methods of preparing salts. Method of preparing soluble salts and method of preparing insoluble salts. Now, soluble salts are prepared by number 1, action of dilute acid on metal. Action of dilute acid on metal. Number 2, action of dilute acid on base. Action of dilute acid on base. Then 3, action of dilute acid on alkali. Action of dilute acid on alkali. Number of insoluble salts are prepared by only 2 methods. Number 1 is direct combination of the constituent elements. Direct combination of the constituent elements. And number 2 is double decomposition. Now, that is telling you that the question can be prepared by double decomposition, and it's telling you that the salt must be an insoluble salt. That is number 1 point you should know. Now, how do you know when a salt is soluble and when a salt is insoluble? Now, recall that salt can exist as trialkyl 4. Salt can also exist as tetraoxosulfates. Salt can exist as trialkyl metallic trialkyl. And salt can exist as chloride, as metallic chloride. Salt can also exist as metallic sulfide. Now, if you look at the head, all metallic trialkyl 5 salts are soluble in water. All of them. Then, all tetraoxosulfate 6 salts as metallic tetraoxosulfate 6 salts are soluble also in water, except that of Ag, Pb, then Pa, and finally Ca, which is highly soluble in water. All of that are soluble except these ones. Now, which means we talk about sodium trialkyl. So it's soluble. And what we're looking for is an insoluble salt. So this one is off, it cannot be. Then barium trialkyl. Remember, I said all trialkyl 5 salts are soluble. So since this one, though is barium, but the trialkyl is a soluble salt. This one led to trialkyl 5 salts. Remember, I said all trialkyl 5 salts are soluble, so this cannot be. Then all chloride are soluble in water. All chloride are soluble in water, except that of Ag, Pb, Hg, Pb, Hg. That is silver chloride, lead 2 chloride, mercury chloride are what? Insoluble. All of that are what? Soluble. So if you look at it, this is silver chloride and it's Ag. Silver chloride will always form white precipitate. White precipitate, of course, when added to any solution that contains what? Chloride ion. So the correct Then 33, the IUPAC name of the compound CH3, CHCl, and CH2OH. Now, see this OH, this is the functional group of all alkanols, or what we call alcohols. And for you to get the IUPAC name correctly, you need to draw the structure. Drawing the structure, you follow it from here. That's C, the first carbon atom surrounded by 3 hydrogen, and the catenated or connected to the second carbon atom, which has 1 hydrogen atom and 1 chlorine atom. Then the third carbon atom contains 2 hydrogen and 1 hydroxyl group. You start numbering from the carbon atom bearing the functional group 1, 2, 3. And since there are 3, we know is a group. Now, but at carbon number 2, there is a substituent attached, which is what? A chloro group attached. So the correct name will be 2-chloro, that's propan-1 or 2-chloropropanol, will also be okay. 2-chloropropan-1 or 2-chloropropanol. If you check the option A, chloropropanol, no. 1-chloropropan-1 or no. 2-chloropropan-3 or no. 2-chloropropan-1 or the correct option is D. Option D is correct. 34. Question 34. Neutron atom of neon with the atomic number of 10 is isoelectronic with. Now, when you talk about isoelectronic, one of the essence of bonding is for an atom of an element to assume or to acquire the electronic structure of nearby noble gases, either by loss of electron or by gain of what? Electron. Now remember that metallic atom has greater tendency of losing electrons to become positively charged. If you look at all of them, they are positively charged. Now, neon is a noble gas with atomic number of what? 10. Now, the first one is potassium. Potassium is number 19, which means it has 19 electrons. The electronic configuration is 2, 8, 8, 1. This is 16, 17, 18, then 19. On losing this, it resembles a nearby noble gas, which is what? 18, argon. So it cannot be isoelectronic with neon. Then option B is magnesium. Magnesium is number 12, that is 2, 8, 2. Of course, 2 plus 8 is 10 plus 2, that is 12. Now, on losing these 2 electrons, it now assumes the what? Electronic structure of the nearby noble gas, which is what? Neon. 8 plus 2, which is 10, which is 10. Then the option C is calcium. Calcium is number 20, that is 2, 8, 8, 2. 16 plus 2, that's 18, 19, 20. On losing these 2 electrons, it now assumes the what? Electronic structure of the nearby noble gas, which is what? 18, that is argon. So if sodium can become isoelectronics with argon, potassium isoelectronics with argon, then magnesium becomes isoelectronics with what? Neon. Then lithium. Lithium is number 3, and the electronic configuration is 2, 1. On losing 1, it becomes 2. So it becomes isoelectronics with helium. So the correct option is option B. It becomes isoelectronics with magnesium becomes isoelectronics with neon on losing each valence electron of what? 2. Yeah. Question 35. Question 35. Which of the following species is the most powerful reducing agent? Recall that Metals have greater tendency or reducing power. Metallic atoms have greater tendency to lose their electrons to become positively charged ions, which we call cations. And most cations have what? Greater reducing power. So they are more of what? Reducing agent compared to what? Non-metallic ions, which are called what? Anions. Now, if you take these are members of group 7, which are called what? Halogens, that is salt formers. Now, starting from the first member of group 7 is F, that's chlorine, followed by chloride ion. The answer is chlorine, bromine, iodine. If you go down, you still have the one aspartame, which is more radioactive. Now, in this order, remember I said that non-metals are more of what? Oxidizing agents, whereas metals are what? Reducing agents. So from here, as the electronegativity decreases, their reactivity also decreases. The most reactive non-metal is fluorine, followed by chlorine, then followed by bromine. Of course, the reactivity is decreasing down the road. As reactivity is decreasing, of course, their strength of oxidation is also what decreasing. So the most powerful oxidizing agent is also fluorine, but the least oxidizing agent. So as oxidizing power or strength is decreasing, then reducing what power is also what increasing. So if this is the most oxidizing agent as fluorine, it means iodine is the most what reducing what agent. So the correct option here is iodine atom. Iodine atom is the most powerful reducing agent out of these halogens. So in these halogens, the first two, fluorine and chlorine, they are gases at room temperature. The third one, which is bromine, is a liquid at room temperature. Then iodine is a solid at room temperature. There is also gradual variations in their water colors. And this is yellow. This is yellowish green. Some book we say greenish yellow. This is reddish brown as bromine. Then iodine is blue black coloration, of course. That. So the correct option is iodine atom. Question 36. The electronic configuration of element Y is IS2, 2S2, 2P6, 3S2, 3P4. Y is therefore has. Now, the first thing you need to do is to count these numbers on top of the word orbitals like SP, DF, the rest of them are what? Number of what? Electrons. These are electrons. So, not the number of electrons. Now, you count this. This is 2 plus 2, 4 plus 6, that's 10. Plus 2, that's 12. 12 plus 4, that should be 16. You ask yourself, since electron, of course, atomic number Z is equal to P and is equal to E. So if the atomic number is, the electron is equal to 16, of course, the atomic number is also what? So Z is equal to 16. Now, which element in the periodic table has the atomic number of 16, and that is what? Oxygen. That's oxygen. Now, since you now know the element, it says option A, Y therefore has mass number of 16. No, oxygen has the atomic number of, the element in the periodic table that has atomic number of 16 is sulfur. Sulfur is number 16 with a mass number of 32, atomic number of 16. Oxygen is 8 with a mass number of 16. Okay. sort of belong to group 6, which are called challenges, meaning all formers and period words for in a periodic table. Hope you learned a lot. Like, comment, and share. And remember to follow Superstar School of Science for more of chemistry lessons. Do you have your contact today? See you in week 7, day 7 of our solution to